This is the extra practice for section 3.5. It says in exercises 1 and 2 graph the linear equation. So one of the things that we should know is, first thing is we notice that the equation is isolated for y. So when it's isolated for y is isolated, we know that it's in y equals mx plus b form, which is slope-intercept form. So what do we notice here? We notice a couple things. First of all, there's only one variable. So this equation is in this form, but there's no x. We don't see an x. We only have a constant, and that constant is going to represent the b. So we can look at this as if this equation is y equals 0x minus 3. And the reason why we might want to consider this is the coefficient of x is going to be my slope. My slope is 0. So my slope is 0, and -3 is my y-intercept. So if I utilize that and I go, we want to graph this, so I always graph my y-intercept first. So -3, 1, 2, 3. I know the equation is going to go through the y-axis at -3, and then slope of 0. 0 as a fraction is 0 over 1, so I go up 0, right 1, up 0, right 1. And I have been able to now graph that line. And graphing that line, let's change the color, let's make it blue. So these are all the solutions to the equation y equals -3. And if we look at those points, 0, -3, 1, -3, and 2, -3, we notice that it doesn't matter what we plug in for x, my output is always going to be -3. No matter what my input, my output is always going to be -3. And that's what it logically says, y equals -3. Y is my output. My output is always going to be -3. What line would be created with an output always -3? Well, it would be a horizontal line. And that line would be at -3. So there's a couple of ways of looking at this problem. We should notice first that there's only one variable. When there's only one variable in your equation, it's either going to be horizontal or vertical. Y equals -3 is going to be that. Now we have x equals 2. Now this is not in y-intercept form, slope-intercept form. This technically is in standard form because technically you have x plus 0y equals 2. Now it gets a little tricky here because if we want to find intercepts, because when it's in standard form, we look for the x and y intercepts when it's in standard form, and we do the cover-up method. So we cover it up. Our x-intercept is 2, so we go where the x-axis or x-axis is 2. Now this, much like we say that our output's always going to be -3, our x is always going to be 2. So find a couple places where x is always going to be 2. It's going to look like that. So did I do arrows on this? I think I did. So that is going to be the equation. Whoop, sorry. That's going to be the equation x equals 2. Because if we look at those coordinates, that is 2, 0. This is 2, 2. And this is 2, 4. So notice each of my x values is always going to be 2, no matter what my y value. If I plug in any y, it's going to turn to 0, right? If we plug in any y value, we're always going to get an output of x equals 2. So notice only one variable when it's x is going to be vertical. Here we have standard form. Use intercepts to grab the linear equation, label the points corresponding to the intercepts. So what we're looking here is this is in standard form, and when we have standard form, we're going to look for the x-intercept. We always know that the y value for the x-intercept is 0, and when we look for the y-intercept, we know that the x value is always going to be 0. And we would plug that in. So we'd start off with this equation, negative 8x plus 12y equals 24. Let's plug in 0 for y. So we're going to plug in 0 for my y value. Shouldn't have done it so much, like that, better. So if we plug that in, we get negative 8x plus 12 times 0 equals 24. And we get negative 8x plus 0 equals 24. Negative 8x equals 24. Divide by negative 8. Divide by negative 8. X equals negative 3. So that is going to be my x-intercept. It's going to cross the x-axis at negative 3. So that's that one point. That's this point. So that produces that point. That's the x-intercept. Now if I want to find the y-intercept, I know that I'm going to plug in 0 for x. So you get negative 8 times 0 plus 12y equals 24. You get 0 plus 12y equals 24. 12y equals 24. Divide by 12. Divide by 12. Y equals 2. And that is my y-intercept. So I go on my y-axis at 2, and I plot that. And that will be my y-intercept. So I have 2 points. Once I have 2 points, I can graph the line. Oh, that was interesting. Once I find 2 points, I can graph the line. There we go. 1, 2, 3. That's going to go right there and there. That looks better. Good. All right, let's draw some arrows. Whoops. Let's draw some arrows. And let's label. So we have negative 3, 0, and we have 2, 0, comma, 2. Good. Graph a line, label the points corresponding to the intercepts. So labeling the points, it looks like that. That's pretty good. I like that. All right. So let's find the intercepts again. X-intercept. We're going to plug in 0 for y. When we plug in 0 for y, we're left with 2x equals 4. Divide by 2, x equals 2. That's my x-intercept. When I find my y-intercept, I'm going to plug in 0 for x. That leaves me with y equals 4. And that's my y-intercept. That's how fast we can do it. That 0 plugging in does away with that term. X is 2. And y is 4. 1, 2, 3, 4. And let's connect the dots. Good. Looks something like that. Let's label them. We want to put arrows. That is 0, 4. This is 2, 0. And we're good. That's how fast you can do these problems. We love them. Now this is not in standard form. My x and y are not on one side and my constant on the other. So I'm going to subtract 3y. And I get 1 plus x minus 3y equals 0. Then I'm going to subtract 1. And I get x minus 3y equals negative 1. Now it's in standard form. And now I'm going to separate them and I'm going to find. I'm going to find my x-intercept. Plugging in 0 for y. Plug in 0 for y. I get x equals negative 1. my y-intercept, I'm going to plug in 0 for x. That's going to do away with that term and leave me with negative 3y equals negative 1. Divide by negative 3 and we get y equals 1/3. So those are my two intercepts. X is negative 1. That's right here. And y equals positive 1/3. Looks something like that. So it's going to look like that. Smartboard's not being very nice to me. Oh, we'll deal with it. Let's draw lines. And let's label. That is negative 1, 0. And this is 0, 1/3. Good. 2 points. All the solutions. Again, not in standard form. So we're going to subtract 1/4 y. That leaves me with 3/4 minus 1/2 x minus 1/4 y equals 0. Let's subtract 3/4 from both sides. And that leaves me with negative 1/2 x minus 1/4 y equals negative 3/4. Now, technically, this looks like it's in standard form, but standard form has some criteria. Standard form A, B, and C must be integers. Integers, meaning whole numbers and their opposites. And the other criteria is A must be positive. So how do I get rid of those fractions? Well, let's get rid of the denominator. 2, 4, and 4, what's the common denominator? 4. So if we multiply everything by 4, we get negative 2x minus y equals negative 3. We would distribute, multiply each term by 4, we get that. Now, all of them are integers, but notice my a value, this is my a, this is my b, this is my c, because standard form looks like this, ax plus by equals c. So the coefficient of x is a, the coefficient of y is b, and c is the constant. So a is not positive, so I'm still not done. I got to multiply by a negative 1, and when we multiply, we got to multiply everything. So if I multiply everything, we get 2x plus y equals 3. Now I can find my x and y intercepts. So I'm going to separate x-intercept, y equals 0. So if I plug in 0 for y, that leaves me with 2x equals 3. Divide by 2, x equals 3/2. That's my x-intercept. My y-intercept, I'm going to plug in 0 for x. And if I plug in 0 for x, it gets rid of that term and leaves me with y equals 3. So my x-intercept is 3/2. That's going to be 1.5. And my y-intercept is 3. 1, 2, 3. I have my 2 points. Let's make my line. Let's put arrows. That's 0, 3. Labeling. And this is 3/2, comma 0. And now I've done all of the things. Use intercepts to graph the linear equation. Label the points corresponding to the intercepts. Good. The school band is selling sweatshirts and baseball caps to raise $9,000 to attend a band competition. The equation 25x plus 10y equals 9,000 models this situation, where x is the number of sweatshirts sold, y is the number of baseball caps sold. Interpret the terms and the coefficients in the equation. Love this. So x is the number of sweatshirts. 25 is the cost per sweatshirt. So each sweatshirt costs $25. Y is the number of baseball caps, and $10 is the cost of each baseball cap. And then 9,000 is going to be how much money we want to raise. So, whoops. So, X equals number of sweatshirts sold. 25 is the cost for each sweatshirt. And so 25x is the total money for sweatshirts raised. Total money raised. Good. Y equals the number of baseball caps sold. $10 is the cost for each baseball cap. And 10Y is the total money raised for baseball caps. And 9,000 is the goal. The goal, the amount you want to raise, the goal, the amount you'd like to raise. Good. All right, graph the equation, interpret the intercepts. So if we have 25x plus 10y equals 9,000, my x-intercept, I'm going to plug in 0 for y, and that gives me 25x equals 9,000. So we'll divide by 25, and x equals, what's that, 9,000 divided by 25 gives you 360. 360. Y-intercept, we're going to plug in 0 for x, and if we plug in, that gets rid of that term, so it just leaves us with 10y equals 9,000. Divide by 10, and we get y equals 900. So if we graph this, let's graph it, we'll be able to sort of see what that represents. So this is our x-intercept. This is our y-intercept. X is the number of sweatshirts. I think x is sweatshirts. Yep. So this is number of sweatshirts. And y is baseball caps. So my x-intercept is 360. Let's make these hundreds. So 1, 2, 3, 60 is that. So that point is 360, 0. And then 900 on our y would be 0, 900. So what does that mean? That's the important thing. And this would be a segment. It would not be a, it would be, and it wouldn't be continuous either. It would be discrete because, and I didn't do a very good job It looks like it's continuous, but it isn't. There will be points there. That's kind of bad. Let's not do that. So there will be points. This will be discrete because you can't sell half a baseball cap or half a sweatshirt. But let's talk about the interpreting the data. So when we say 0,900, that means that we're selling 0 sweatshirts and 900 baseball caps, which would equate to $9,000. Or in this one, 360, 0, that means we would sell 360 sweatshirts and 0 baseball caps, which would equate to the $9,000. And as you know, there are a finite number of other solutions between that. We cannot draw a continuous line because you can't have partial sweatshirts or partial baseball caps. So it would be points and it would be discrete. So I don't know if that question will come up. Let's see. Dance team has 2 competitions. Nope, it doesn't go into that. But important for us to understand it when we interpret it. A dance team has 2 competitions on the same day. The coaches decide to split the 96-member team, sending some to each competition. Competition A requires 4-member dance teams per event, and competition B requires 6-member dance teams per event. Write an equation in standard form that models this situation. Do the intercepts of the graph make sense in this context? All right, so we have split. So we're going to have 4A plus 6B equals 96. And the reason why I wrote that is because however many A groups, each A group consists of 4 people. So we would take, if I have one A group, we would have 4 members. If I have 2 A groups, that would be 8. So if A is 2, you'd multiply it by 4 and you'd get 8. And then for every B competition group requires 6 members. So, and we want the sum of those 2 groups to add up to 96. Do the intercepts of the graph make sense in this context? So if I find the intercepts, if I find the A intercept, I'm going to plug in B for 0. So that leaves me with 4A equals 96. Divide by 4, divide by 4, and we get A equals 24. So that's going to be my A intercept. So I would have 24 groups going to the A competition, and since each group in the A competition consists of 4 members, 24 times 4 gives me 96, and there would be 0 members going to the B competition because there wouldn't be anybody left. It's all 96 members. And if I want to find the B intercept, I'm going to plug in 0 for A, and that's going to get rid of that term, and we're left with 6B equals 96. Divide by 6, divide by 6, and B is going to equal 116. So that intercept would represent, if I sent 16 groups to competition B, remember each group consists of 6 members, so 16 times 6 gives me 96, and there would be no members left to go to competition A. So that's what, do the intercepts of the graph make sense? Yeah, makes sense. I don't think I was asked to graph it yet, write an equation. We wrote it in standard form, and that's good. How many teams should the coaches send to each competition so that all of the members attend a competition? Well, how many teams should the coaches send to each competition so that all of the members attend a competition? Well, it's going to be somewhere between that form. So if we pull this out of here, and we would label, let's label A as the x-axis and B as the y-axis. So if my intercepts, my A intercept was 24. So 24, so let's, what was my other one? 24 and 16, 24 and 16. So can we go by fives? So 24, 5, 10, 15, 20, 25. So 5, 10, 15, 20, 25. And what we say, 24 and 16, 5, 10, 15, 20. So those are the intercepts. So that is 0, 16. And B is, remember, B is 6-member teams. A is 4-member teams. And this is going to be 24, 0, I think was our number. So we would find something in between there. So I could also find a solution using that equation. Let's find a specific situation. So we have 4a plus 6b equals 96. So if I plug in 1 for a, so if I send one group to competition A, how many am I going to send to B? So how many groups? So that gives me equals 96. Let's minus 4. Minus 4. So this will be good. This will be good. So 6b equals 92. Divide by 6. Divide by 6. We get b equals. And what do we notice here? 92 divided by 6 is not going to be a whole number. 15 and 1/3. Well, you can't send a partial group. So I can't do that. There will be people left over. I can send 15 groups to competition B, comp B, but there would be people left over, not going to a competition. So I cannot send one group to A. So that is a no-go. So that would not be a solution. Can you tell what numbers you'd want to do? Can you do 2? Can you send 2 to A? Nope. Can you send 3? Do you see why you can send 3? So 4a plus 6b equals 96. Do you know why I was able to plug in 3? Why I liked 3? 12 equals 6b equals 96 minus 12 minus 12. 6b equals 84. And 6 does go into 84. B equals 14. So in that situation where I send 3, where I send 3 to comp A, competition A, and 14 to competition B works out where all 96 members are attending one of the competitions. Why? Because it was a multiple of 6. 4 times 3 is 12. 12 is a multiple of 6. So that was going to work out. So there are a couple of solutions, not an infinite number of solutions, and it again is not continuous. It would be discrete. All right, so that is one situation where everybody goes to a competition. So we can't just pick any random number to plug in. We would have to be thoughtful about what the solutions are. Good one. That's good thinking. Good comprehension. Good luck.